Okay, here let's talk about just very briefly the concept of ion formation. This is actually a very important idea to get inside one's brain because although it may or may not seem a fundamental idea, it has a lot of inference and a lot of implications to chemistry. So ion formation requires electron transfer from, of course, one atom to another. Recall that cations, positively charged, are losing electrons. So those electrons have to go somewhere. All right? Those electrons have to relocate. Therefore, if you think about anions, those are negatively charged. Those are gaining electrons. Therefore, electrons come from somewhere. And of course, hopefully you see the direct correlation. If you have something that's losing electrons and something that's gaining electrons, then electrons are transferred from, of course, atoms that form cations to atoms that form anions. Okay. Since matter is conserved, it can neither be created nor destroyed. That includes subatomic particles. Electrons have to come from somewhere and go somewhere. The electrons are transferred from cations to anions. I'm sure you've already got that idea down. Brilliant. Now, what that also means, though, is that we can think about this, for example, if we had the atom sodium with a Lewis dot structure of 1 dot for an electron, and we add to that chlorine, which has an electron dot structure like so. It's going to be 7 electrons. You will have an electron transferred from sodium onto chlorine, like so, to give you sodium that will be now positively charged plus a chlorine. I shouldn't put the positive charge inside. Let's correctly locate that. Chlorine that will now have a complete octet like so. We'll put in brackets as well. Chlorine will be negatively charged. Sodium will be positively charged. Okay, now I'm certain that you have heard the fantastic age-old adage that is that opposites attract. And since you know that positively charged things are opposite of negatively charged things, then if those things will be attracted to form, if you have a positively charged ion and a negatively charged ion, you will form a compound. And since those are ions, it will be an ionic compound. And the attraction between charged particles is known as electrostatic attraction. Now that you've got that down, something to keep in mind is because of this, you're constantly going to have positive attracted, negative attracted, positive attracted, negative attracted, positive attracted, negative. And so therefore, there is no finite or discrete or specifically sized particle of an ionic compound, okay? And because of that, this means that there is no formula of a specific size that tells you this is that compound, okay? Well, there is, but that formula, what we use is we use the most reduced ratio of ions, okay, that gives you a neutral compound. And what that's called is the formula unit. Now, I want to specify this. The formula unit is the most reduced ratio of ions that yields that neutral compound, okay? So very quickly, we can see, for example, if you've got sodium that's going to give you a positive ion, and you add that to chlorine, that's a negatively charged ion, you're going to get a single unit of sodium chloride, which of course is known as table salt. And the salt that you use on your food in general is sodium chloride. Beyond that, if we were to combine something, for example, let's keep with sodium, which its ion will be positively charged, and let us combine that with something like, let's say, oxygen, which forms a 2- ion based upon what you would predict from the periodic table, then what we would call sodium oxide, and we'll come to that in a very soon upcoming lecture to explain naming. That will be a ratio of 2 sodiums to 1 oxygen. Okay, see that that establishes our neutral state. You could have a 2+ ion of calcium plus some fluorine or a fluoride anion. We'll go into the naming soon. You'll get CaF2. You can see that we maintain the ratio of particles to give us the formula unit that gives us a neutral compound. Okay, I'm going to stop this lecture here.